An object moves with an acceleration function given by this a of t. Its initial velocity is given, so we have v of 0 in feet per second, and its initial position is this s of 0, which is going to be 0 feet. And we need to find its position function after t seconds. So we want to remember the relationship between all these three functions: acceleration, velocity, and position. So we know that s of t is the one that we typically would start with, right? And then we take the first derivative, and it's called velocity. And then we took a second derivative of position and got to the acceleration function. Now we're starting the other way. We're given a of t, and we're trying to work our way back to find the position function. So we need to take the antiderivative twice to get from acceleration back to position. So we're going to actually solve two initial value problems like we practiced before. We're going to do one IVP to get back to velocity and another IVP to get back to position. So we've practiced this without a word problem before. It's not going to be any different. It's our same three steps, but we're going to do them twice. So our first step, we're starting with acceleration, and we want to get back to, well, it's going to have to be velocity. You can't get all the way up to the position function without going through velocity first. So I'm going to take the antiderivative of acceleration to get back to velocity. So I'm going to take the antiderivative of a really simple short function, which is nice. So I'm going to take the antiderivative of negative 32, and instead of dx, I'm going to write dt because I notice this t here. It's with respect to time instead of just x, our regular variable. So v of t, well, it's just a constant. The antiderivative of any constant is that constant, usually times x plus c, but this one's going to be times t plus c, just because I noticed we were given a of t and not a of x, so we're going to use t's here. All right, so there's our first step. Our second step is going to be to figure out what this c is. Well, we are given the velocity at 0 seconds has to be 20 feet. So we're told v of 0 has to equal 20. So we're going to do negative 32 and swap that t for a 0 plus c has to equal 20 feet per second. So of course, negative 32 times 0 is just going to be 0 plus c is 20, which means c is 20. So our third and final step is writing the overall function. V of t is going to be negative 32 t plus 20. Okay, so now we're at the velocity function, but it says find the position after t seconds. So we want the function for position, which is called s, after t seconds, so we want to find s of t. So we're going to do our next initial value problem. We're going to start with velocity and get back up to position. So the first step is to take the antiderivative. We're going to get s of t when we take the antiderivative of our v of t, which was negative 32t plus 20 dt. So we're going to take our antiderivative. So we're going to do negative 32, keep our constant multiple. T is to the first power, so 1 plus 1 is 2. So negative 32 divided by 2, t to the 2, plus 20 times t plus c, because it's a constant. So that constant times t plus c. And of course, we could write this a little bit nicer because negative 32 divided by 2 is negative 16t squared plus 20t plus c. And our second step is to use the point we're given, and it's that s of 0 is 0. So we'd have negative 16 times 0 squared plus 20 times 0 plus c is supposed to equal 0. And so negative 16 times 0 squared plus 20 times 0 is all going to be 0 plus c is 0, which means c has to be 0. So our position function is just going to be s of t is negative 16t squared plus 20t. We could write plus 0 at the end if we want to, since that's what C is 0, but you don't have to write a plus 0. And there we have it, 2 initial value problems. One thing I do want to note to make it a little bit simpler is a pattern here. So we have v of t is 20, or sorry, v of 0 is 20, which gave us c must have been 20. S of 0 was 0, so c was 0. So we can kind of recognize things and take shortcuts if we want to. Or I'm not a memorization kind of person. I would rather just have my one method that works on everything. It might be a little bit slower, but I don't have to memorize a bunch of small facts. But there is a pattern to this. If you're given the value at 0, you're given C, the initial value.